Okay, resuming from what we have had with matrices and linear transformations. Now, if we look at this from another angle, no pun intended, but we are looking into rotations. And for what we have between transformations and rotations, okay, let's say we have a transformation to be maintained within two dimensions, okay, where we have the x01 and x02 axis. Okay, so think of like x02 and the y-axis as being one and the same. And let's say we let this type of transformation to be one where we have the rotation of each point in R2 about the origin through an angle phi, okay, with a counterclockwise rotation for a positive angle. Okay, so and we'll be looking at the angles in terms of radians. And just to give you a little bit of a visual, okay, I just picked out arbitrary coordinates, okay, where we have, well, for the not so arbitrary part, okay, well, let's say we have 2 points on both the x1 and x2 axis where we have going out 1 unit to the right on x1 where we have the coordinates 1, 0. And then we have going up 1 unit vertically where we have on the x2 axis where we have the order pair 0, 1. And just to give you a little bit of visual, okay, you had the same size triangles, or what should be the same size triangles formed, and you have from the starting points you have the same measured angle alpha, or I should say in this case phi, that is going to be projected out. Okay, and let's say that we have along the x1 axis have going out 4/5 of a unit, then up 3/5 of a unit, and we have just with the Pythagorean equation, okay, we had the sum of the squares of 4/5 and 3/5 will be at 1. And okay, so you have with your ordered pair, you have your x1, x2, where we have 4/5 and 3/5. And in terms of what we have with the trig functions, we have the cosine of phi as well as the sine of phi. And just looking at the same type of motion, okay, just say that we have if you had the same triangle taking a quarter turn and starting from 0, 1 as opposed to 1, 0, okay, you have going up 3/5 of a unit translates to shifting out to the left 3/5 of a unit. So we have going minus 3/5 of a unit, and we have where we have going out to the right 4/5 quarter turn translates to going up 4/5 of a unit. Okay, so in terms of our x1, x2 coordinate system, okay, you have your coordinates to be what's going to be negative 3/5 and 4/5. And in terms of the vernacular that we have with our trig functions, again, we started out with 4/5 as being cosine of phi. And again, 4/5 reappears here as the second order pair, so you have the cosine of phi. First order pair, we have negative 3/5, and that's going to be the opposite sign of what we had with the sine function. So we have in this manner, x1 and x02. For this second point projected, this will be the negative of the sine of phi and the cosine of phi. So just with these visuals, you have in the manner of rotation, you have like 1, 0, or in matrix form, you have 1, 0, which would rotate into 4/5 and 3/5. Okay, so you have in this case, so 1 becomes 4/5 and 0 becomes 3/5, and so that is in the manner of cosine phi, sine of phi. And for 0, 1, okay, you had that will rotate into negative 3/5 and 4/5. So we have in this particular case, right, so we have the negative of the sine of phi, cosine of phi. So we have with the unique matrix, okay, again, that is going to be the matrix formed by the transformations of E1 and E2, and say the transformation of 1, 0 and that of 0, 1. And we have with the formula, have first column, we have in the transformation, you have cosine phi, sine of phi. And the second column, again, we have negative sine of phi, cosine of phi. And in terms of what we had with our specified ordered pairs for this particular example, the first column, in the transformation, we have 4/5 and 3/5. Second column, we have negative 3/5 and 4/5. Okay, so for what we have among our examples, it says to find A, the standard matrix of T given, and we will have just maintaining just in the two dimensions. Okay, say we have the transformation is going to involve rotating points about the origin through pi over 6 radians. Okay, so to maintain a positive angle, we will have the rotation to be counterclockwise, and we have that phi is equal to pi over 6. And taking what we have for A, again, just adopting the cosine, sine, negative sine, and the cosine of phi, where this time we have phi at pi over 6, and filling in the first column for the cosine, the sine of pi over 6, we're going to have the square root of 3 over 2 and 1/2. And for the second column, where we have respectively the negative of the sine of pi over 6 and the cosine of pi over 6, we will end up with the values of negative 1/2 as well as the square root of 3 over 2. Now, if you had the rotation to be going clockwise, where instead of moving pi over 6 radians, we instead have moving negative pi over 6 radians. And so we have with phi at negative pi over 6, and just filling in using our algorithm here, it's going to turn out that for this particular matrix, first column will result as the square root of 3 over 2. And we have with the sine of negative pi over 6, we have a minus 1/2. And at negative pi over 6 radians, the opposite sign of the sine of negative pi over 6, this will be at 1/2. And for the cosine of negative pi over 6, this will come out to the square root of 3 over 2. All right, now, so these are just a couple of quick cases of what we have with rotations. Now, in the case of reflections, now the author uses the identity matrix 1001 to kind of show some cases where you have the results whenever you have the reflection of particular squares about particular axes as well as the origin. And once you cross over to matrices other than what is the identity matrix, it's like the visualization can get a little bit confusing. And if you have the spatial ability and all that to see the results in advance, then I say more power to you. But let's say that if you have a coefficient matrix, okay, where we have 1, 3, 2, 5, and it says to determine the resulting matrix whenever A is going to be reflected through the x01 axis. So think of the x01 axis as being the just the x-axis, and if you rotate, now your x values would stay the same, but what is otherwise your y values, okay, they're going to change signs. And in the vernacular, what we have the x01, x02 coordinate system, only your x2 values will change signs. So those would be the bottom numbers. So if I reflect 1, 3, 2, 5 through the x01 axis, okay, we'll end up with 1, 3 remaining the same, and 2, 5 is going to be transformed to negative 2, negative 5. Now, in terms of reflecting through the vertical, or in this case, the x2 axis, now reflecting about the vertical axis, now your x01 values are going to stay the same, but your vertical values or vertical coordinates will stay the same. So only x01 is going to change signs, and those will be the top numbers. So we have in the transformation, we have upon reflecting 1, 3, 2, 5 changes over to negative 1, negative 3, and 2, 5. And in the third case, or if you have reflection through the line x02 equals x01, what happens in consequence is that your top and bottom numbers are going to change places. Like, okay, just like think of it kind of like the inverse of a one-to-one function. What was x becomes y, and vice versa. Well, in this case, you have the same kind of situation here. What was x1 becomes x2, and vice versa. So the top numbers are transformed to the bottom, and vice versa. So we have, after this reflection, we have 2, 5 at the top, and 1, 3 at the bottom. And we have, if you have reflection through the line x02 equal to negative x01, okay, you have it kind of an inverse, not in the reciprocal sense, but where x becomes y, but you have a sign change, so x1 becomes negative x02, and x02 becomes negative x01. So we have, after transforming the top numbers to the bottom and vice versa, we then apply the opposite signs. So we have 1, 3 to become not just 2, 5, but negative 2, negative 5, and 2, 5 becomes not just 1, 3, but negative 1, negative 3. And another scenario is that if you have reflection of A through the origin, you're going to have sign changes throughout. What is positive becomes negative, and vice versa. And since we have all positive coefficients in A, well, the reflection through the origin is going to result as a matrix that will have all negative values. So you have -1, -3, as well as -2, -5. And let's say that just sort of amalgamating what we have with rotations and reflections. Okay, say you have, just kind of going back to what we have with rotation about the origin through pi over 6. Okay, we had this set of results, but let's say if you have reflecting through the x1 axis. And in this particular case, only the y values for the x2 values are going to change over. So we have with reflection, okay, your bottom numbers, only your bottom numbers will change signs. So we have -1/2 and the square root of 3 over 2 at the bottom. Okay, and now let's say if you had the same rotation, but this time we have reflecting the points through the origin. And this will mean that after the rotation, going through pi over 6 radians, you'll have sign change everywhere. What is positive becomes negative and vice versa. And so we have here the resulting matrix after all the steps. Now, third case, same rotation, but if you reflect the points through the line x of 2 equal to x of 1, so your top numbers become your bottom numbers and vice versa. So we have this particular result. What was at the bottom is at the top, and what was at the top ends up on the bottom. And let's say that if you had the same rotation, now you're reflecting the points through the x of 2 axis. Remember, think of like reflecting about the y-axis on the x values will change. And if you have reflecting points about the x of 2 axis, your top numbers, your x of 1 numbers will change signs. So the only change will be the top numbers, where we have upon reflecting, you have negative square root of 3 over 2 as well as 1/2 at the top. And one more scenario, if you have reflecting points through the line x of 2 is equal to negative x of 1, remember your top numbers become your bottom numbers and vice versa with sign changes applied. So we have what was at the top, we have square root of 3 over 2, negative 1/2 at the top, and those will be moved to the bottom and sign changes applied. And we had the vice versa scenario to be applied, where we had the bottom numbers to be applied to the top with also sign changes applied. So after this particular rotation and reflecting through the line x of 2 equals negative x of 1, we had the following 2 by 2 matrix, where we had the first column with negative 1/2, negative square root of 3 over 2, and the second column we have square root of 3 over 2 and 1/2.